Hi guys, Mr. Hill here with your maths for today. The question we're looking at today, our learning objective, can I add and subtract fractions? So before we get started with our lesson, something to get your brain warmed up and ready to go. Pause here to have a go at these. How did we get on? So question 1, 5 apples plus 2 apples. We've of course got 7 apples. 5/3 plus 2/3. We've got 7/3. Looking at question 3, 7/9 take away 4/9. We can do this one of two ways. We can use a bar model, which we've drawn on the screen. We can also look at our fractions and we can see that we have the same denominator. So we're using the same fraction. So 7/9 in the bar model, take 4 away. I count what's left, 1, 2, 3. My answer is 3/9. We do exactly the same for question 4. We have a bar split into 11. I've got 8/11 shaded in. I need to take away 5 and 1 more, and I'm left with 1, 2 in my bar model. So the answer to that one is 2/11. So moving forward, Dexter eats 2/5 of his chocolate bar. Alex eats 4/5 of her chocolate bar. Do they eat more than one whole chocolate bar together? So we need to do some working out here. So I've got my bar here with 2/5, that's Dexter's chocolate bar. I've got Alex's chocolate bar underneath with 4/5. Now we don't need to do any equivalence here because our denominators are already the same. And as long as the denominators are the same, we can add the numerators really simply. We just add 2 and 4 together, which will give us 6/5. So when we're adding with the same denominator, it still will, the denominator stays the same all the way through. Only the numerator will change. The same with subtraction. The denominator will stay the same all the way through. It's only the numerator that changes. So we know 6/5 is an improper fraction. So they must eat more than one whole chocolate bar together. Let's check. Let's just move one of these squares. So I've eaten one whole chocolate bar, that's 5/5 of a bar, and I've got one part of the next bar left out that's been eaten. So I've only got left 4/5 of the chocolate bar. So 6/5, as we said, is 1 whole and 1/5. So yes, they do eat more than one whole bar. Okay, over to you. I've got 3/7 plus 6/7, which equals an improper fraction. And then what you need to do is turn that improper fraction into a mixed number fraction. Pause here to do this. Okay, how have we got on with that? So we don't need to do any equivalence. Our denominators are the same. So I can add 3 and 6 together to give me 9, and remembering the denominator stays the same all the way through. We just add the numerators together. 9/7. I know that there are one lot of 7 in 9, and I will have 2/7 left over. So that's our answer, 1 and 2/7. So we can show it another way as well. We can use a part whole model. So we've got 9/7. So I can take 7/7. I know 7/7 is equivalent to 1. And I know I've got 2/7 left. And then I can exchange my 7/7 for 1 whole. And then I've got my mixed number fraction there at the bottom, 1 and 2/7. So this is a way of using a part whole model to help us to start making improper fractions into mixed number fractions. So here we've got 3 fractions being added together. I've got 3/8 plus 3/8 plus 7/8, which gives me a total of 13. So 3 add 3 add 7 makes 13, and that's 13/8. So remembering when we're adding fractions with the same denominator, we don't need to find any equivalence. We're just adding the numerators together. So using my part whole model here, I'm going to put my 13/8 in the top. That's my whole. And I need to find the parts. So I know 8/8 is worth 1 whole. It's equivalent to 1 complete fraction. And I've got 5/8 left over. So just to show you, so I've got 13/8 as my whole. I'm taking 8/8 away. So my denominators are the same. I just need to do 13 take away 8. That will leave me with my 5/8. So that's where we get this 5/8 from that goes in here. And I know that 8/8 is equivalent to 1. So my answer for this as a mixed number is 1 and 5/8. Okay, your turn now. Pause here, have a go. How do we get on? So the first thing we need to do, we're going to look at the denominators. They're all the same, so we're going to add the numerators together. So I've got 8 plus 10 plus 6. I know we're adding all of these together. 8 plus 6 is 14. 1 and 1 for 2. So we have got 24/11. Now what I do need to do now is convert this from a mixed number fraction into, no, from an improper fraction into a mixed number fraction. I'm getting ahead of myself. So we can use our part whole model. I can take 11/11 out. So if I've done that, I've got 24/11. I can take 11/11 away. If I've done that, my denominators are the same, so they're going to stay the same all the way through. 24 take away 11 leaves me with 13. So I can still take another 11/11 out. So I'm going to, you remember that 11/11 is equivalent to 1. So where the numerator and the denominator are the same, it's equal to 1. I'm going to take another lot of 11/11 out. So I've got 13/11 left. And I'm going to take another 11/11 out, which is going to leave me with 2 11s. So our denominator staying the same. We're subtracting 11 from 13 to leave us with 2. So I've got another 1 there, 11/11. What's the remainder is 2 11s. So the wholes, I've got 2 of those, and I've got 2 11s as my remainder. So I have 2 and 2 11s. So have a go with this one. We've got 11/8 take away 2/8. So we're subtracting this time. It's exactly the same process. The denominators are the same. So we just need to look at the numerators. So I've got 1 lot of 8/8 and my extra 3/8. 8 plus 3 makes 11. And I need to take 2 away. So I'm going to take those 2 away. And then I can count up how many I've got left. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So my improper fraction as my answer is 9/8. So I've got 1 whole and 1/8. So if we're going to use our part whole model to help us here, we'll have 9/8 in the top. I'm going to take 8/8 here because I know that's equivalent to 1. And I've got 1/8 left over because I know 8 plus 1 equals 9. So that will become 1. So that's how we get to 1 and 1/8. Okay, your turn here. So we're subtracting fractions. Use the bar model to help. You'll have an improper fraction. You'll need to change it into a mixed number. Pause here to do this. How did we get on with this one? So using our bar model, I'm taking 1/4 away. So it leaves me with 6/4. And 6/4, we'll use our part whole model. We'll take 4/4. We know 4/4 is equivalent to 1 whole. And we'll also take out the other 2/4 because I know that 2 add 4 makes 6. So 4/4 becomes 1. So where the numerator equals the denominator, that's worth 1. And 2/4 we can simplify down to 1/2. So our numerator is half of our denominator. So the answer to this question is 1 and 1/2. So as we move forward, we've got 2 sets of fifths to subtract here. Have a think. How would you solve this one? Pause here to have a go. Okay, how did we get on? So 21 fifths, take away 2 fifths, take away 3 fifths. So 21 take away 2 leaves me with 19 fifths. 19 take away 3 leaves me with 16 fifths. Could leave 16 fifths as an answer, but we need to go one more step and make it into a mixed number fraction. So we use our part whole model. In at the top, we have 16 fifths. I can take one lot of 5 fifths, 2 lots of 5 fifths. Oops, not written that terribly well. And I can take a 3rd lot of 5 fifths. So here I've got 5, 10, 15 fifths, and I've got 1 fifth left over to get me to the 16. All of these are equivalent. So this one, and this one are all equivalent to 1. We have the denominator and the numerator are equal. So that's where we get the 3 from. So these 3 here, so these 3 is where we get this one from, our 3 wholes, and we have 1 fifth. That's the remainder we've got left over. Okay, over to you. Have a go with these. You don't have any equivalents to find with these. The denominators are all the same. You're adding and subtracting, so you only need to look at the numerators. And if you've got an improper fraction, you need to write it as a mixed number fraction and look out for the equivalent fractions for quarters, halves, thirds, and sixths. Pause here to have a go at these. Right, are we ready for some answers? Let's move on. Question 1, using bar models to help you. So we can use the bar models and we can see that we've got 4 fifths plus 3 fifths. It gives us 7 fifths in total. And with the bar models, we can see we've got 1 whole bar model and 2 fifths left over. So that we've got 1 whole and 2 fifths. B, we're adding 6 fifths and 3 fifths. Again, we'll need 2 bar models in 5 parts, 1 full and 1 with 4 fifths. Our answer is 1 and 4 fifths. C, we've got 8 fifths to begin with. So again, we need our bar model split into 5. We have 8 fifths to start off with. We've taken 6 fifths off, so we've crossed those out and we're left with 2 fifths. Our fourth question, D. 9 fifths take away 3 fifths, leaves us with 6 fifths. So we've used our bar model we've got one blank space underneath my head, but we didn't need that one because we've only needed 9. I've crossed out 3 because that's how many I'm taking away, and I'm left with 6. Remembering that the denominator doesn't change, so we're only taking away the numerators. 6/5 becomes 1 1/5. So we've got one whole bar of 5 and 1/5 in the next bar along. So we've got 1 whole and 1/5 as our answer to that one. Question 2, completing the calculations. A, 4/7 plus 2/7 to give us 6/7. And you can pause here and work your way through, checking your answers as you go. Okay, all your answers checked? Let's move forward. Question 3, what could the missing numerators be? I've asked you for 6 different possibilities. So long as they are 2 integers, 2 whole numbers that add up to 13, you're good. You've got it. So 1 and 12, 2 and 11, 3 and 10, 4 and 9, 5 and 8, 7 and 6, and any version of those. So you could have 9 and 4, 12 and 1. So long as we've got 6, and so long as our numerators add up to 13, we've got it. Let's move forward. Now, I've got a tricky one here. I've got a missing number, take away 7/5, take away 8/5 equals 4. So I need to start working in the inverse to work these out. So I need to work out how many fifths I've got in 4. So if 1 equals 5/5, 2 will be 10/5, 3 will be 15/5, 4 will be 20/5. So I'm going to use an improper fraction to solve this problem. So something over 5, take away 7/5, take away 8/5, leaves me with 20/5 as my answer. So I need to add 7/5, so I've got 28/5, so 20 plus 8. And then I need to add back my, right, I'm going to show you this slightly differently because I've not made a great job of doing this. So we've got 20/5 here. We need to add 8/5, then add 7/5. So 20/5 plus 8/5 equals 28/5. So I'm working back through my calculation. So I've taken away 8/5 on the here, so I need to add it back. So I've got 28/5. I've still got 7/5, so I'm going to add this back on as well. Here, that will give me my answer of 35/5. So where we've taken away from the beginning number to come down to get to 4 or 20/5, we need to add those back on to see where we've started. So there we are, there's 35/5. So we've got something similar here. I've got 5/2 plus 1/2 equals something over 9 plus 14/9. So we need to look at how we're going to solve this one. What we could do is multiply and make things really hard for ourselves, or we can look for equivalence. So if I add 5/2 and 1/2 together, I get 6/2 or 6/2. So remembering that when we're adding fractions, if the denominators are the same, we're just adding the numerators together. So I now need to work out what this is as a mixed number. So it's 3. So I know that 2 halves make 1. I've got 6 halves, so I've got 3 in total. So I now need to convert my 3 into ninths. So remembering 9/9 is 1, 18/9 would be 2, 27/9 is 3. So now to solve this, I would do 27 take away 14. We've got this here to leave me with our number here. So 27 take away 14 ninths will leave me with 13 ninths. Remembering that we're only subtracting the numerators or adding the numerators, we are not adding or subtracting the denominators. They stay the same all the way through. Okay, thinking about what we've just done. Have a think, have a go at these yourself. Pause the video here. How did we get on with these ones? If you feel like you're not entirely certain of the method, have a look back, re-go through the last couple of minutes of the video, and then come back to these questions. So we need to convert 4 into 6. So 6 sixths is 1, 12 sixths would be 2, 18 sixths is 3, 24 sixths is 4. So now we know this. I need to work out what I need to take away from 29 to leave me with 24. So I can do 29 take away 24 to leave me with 5. So 29 take away 5 sixths. Sorry, 29 sixths take away 5 sixths equals 4 wholes, which is 24 over 6. Solving part 2, 17 thirds take away 2 thirds is 15 thirds. So I've got an improper fraction here, so I'm going to turn that into a mixed number. So it comes out equally as 5. So 5 lots of 3 thirds would make 15 thirds or 5 wholes. So knowing that I need to be equal to 5, I know that 5 equals 50 lots of 10, or 50 tenths rather. So 1 is 10 tenths, 2 is 20 tenths, 3 would be 30 tenths, 4 is 40 tenths, 5 is 50 tenths. So I need to work out what I add to 17 to make 50. And I can do this by doing 50 take away 17. So can't take 7 away from 0, so I need to exchange down. 7 from 10 leaves me with 3. 4 take away 1 leaves me with 3. So my answer was 33. So moving forward to something that's going to take a little bit of thinking, our reasoning question. Mo and Tommy each have a jug of milk. Mo's jug contains 5/7 of a litre less milk than Tommy's. The total milk in the 2 jugs is 3 2/7 of a litre. How much milk does Mo have? So Mo has this much milk. Tommy has this much milk. And together they have 3 2/7 of a litre of milk. We also know from the question that Tommy has 5/7 of a litre more. So we can take that out. But how do we do it? Well, we need to convert 3 2/7 into an improper fraction and then take away the 5/7. So I can't do it easily with 3 wholes and 2/7. So we turn 3 2/7 into an improper fraction. So we need to remember, if my pen would cooperate with me this afternoon, 1 equals 7/7, 2 equals 14/7, 3 equals 21/7. Knowing that we've got 2/7 there as well, so we need to add those 2/7 on the 23/7. So that's how we get to 23/7. We can then subtract the 5/7 from that to get our answer. It leaves us with 18/7. All we need to do now, we're left with 2 equal parts. I can divide 18 by 2 to leave me with 9/7 for Mo, 9/7 for Tommy. What we do need to do as well, we need to add back in the 5/7 we subtracted from Tommy's. So Mo has got 9/7, which is 1 litre and 2/7 of a litre. If we were asked to find out how much milk Tommy has, we would add the 5/7 and the 9/7 together. Your turn now. Using what we've done, answer these questions. Pause here to do that. How did we get on? Moving forward, the answers for you. So Dora has 2 3/8 of a litre of juice. She pours out 9/8. So working this one out is very similar to what we've just done. So 2 3/8. I need to turn this into an improper fraction. So 1 is 8/8. 2 is 16/8. And I've got the 3/8 I need to add on as well. So I've got 3/8 there, which will give me 19/8. I then need to take away 9/8. So 19 take away 9 will leave me with 10/8. And then now I can use my number knowledge. I know that 8 goes into 10. I'll get 1 whole and I'll have 2 8s left over. I could leave it like this, but I know that I can simplify 2 and 8. I can divide both by 2 and it will become 1 1/4. Finding the missing numerators, we're adding and subtracting. The denominators are all the same. So what we're looking for is the numbers to work out. A, B, and C, nice and simple. D, E, and F, we get into mixed numbers, and then we're back to simple numbers and working out what the wholes need to be at the end for the others. So if you feel like you've struggled a little bit with this, go back in the video, find the part where we did these, re-watch over again, maybe write down a couple of these questions, bring them back with you and practice using the method that we're teaching today and work them through and understand the process for doing it. If you're really stuck, we've got a live session during the week. We can focus on it, we can help you, or you can always message through Teams. Happy to help. Question 6 and 7, moving us forward. Here are some fraction cards. So using the cards to write the pairs of fractions with a total of 2, we could have had 1 7/8 plus 1/8, 13/8 plus 3/8, and 9/8 plus 7/8. So where we've got the ones written as improper fractions, so long as our numerators equal 16, which is 2 lots of 8, we will be correct. Annie and Dexter have a skipping rope. Annie's rope is 3/4 of a metre shorter than Dexter's rope. The ropes are 3/4 of a metre altogether. How long is each rope? So that's exactly the same as we did for working out the milk and how much Mo had in his jug of milk. So what we need to remember, we've got 1 rope and we've got 2 ropes, and the difference between the two here is 3/4 of a metre. So if I have 13/4, if I'm going to take the 3/4 away, that will leave me with 10/4 to then share between 2 people. So 10 divided by 2, each part here is 5¼ meters. So Annie's rope, she will have 5¼ which is equivalent to 1¼ Annie's rope, we have got 5/4 plus 3/4, which will give us 8/4. 8 is double 4, so 8 is equal to 2 meters. And I forgot my meters there. I know some of you will have noticed that. Well done today. You've worked really hard. You've worked really well. Good luck. Stay safe, and we'll see you guys again very soon.